time attending this conference here, and I'm really excited to speak to you today. I've heard 2 talks previously on image and speech, and now I'm going to touch a bit more about text. So I'm an engineer manager at Quora, and I'm going to talk about various applications of machine learning algorithms to solve product problems. So before I start, can you please raise your hand if you're already a Quora user? Cool. I see about like 1/3 to a half of the audience here. That's great. I hope this number will go up after this talk. Okay. So with that in mind, let me first give you a quick introduction of what Quora is. So Quora is the best source for human knowledge on the internet. And our mission is to share and grow the world's knowledge. And we mainly focus on the format of questions and answers to achieve that mission. So every day, people come to our product to ask questions about knowledge they care about, to read answers that interest them, and to write answers that they want to share with other people. We have millions of questions and answers and users, and we have thousands of topics in the product. And so this is very big data. And then we think about our mission, and then we think how we can map that to business logics and objective functions, right, in the machine learning world. So there are 3 things that we care about the most: quality, relevance, and demand. And these terms may be very familiar with you on different settings, and of course, different businesses care about different things. If you work on ads optimization, you might care a bit more about relevance rather than quality. For Wikipedia, they might care more about quality rather than relevance. But for us, all 3 dimensions must go hand in hand, otherwise we won't be successful. We care a lot about quality because we're trying to grow organically a knowledge base that's useful and fun for the users. But we don't want jokes or memes, things that might be relevant to some users, but we don't consider as good knowledge to share and grow. We also care a lot about relevance, and that's because we want to make sure that we get the right knowledge to the right people. And then lastly, with demand, of course we want to get knowledge about niche topics, but then we care more about things that most people would want to know about. So then, once we're clear of the mission and then the different objective functions or dimensions that we want to optimize for, let's take a look at our data to see how we can solve these problems. Before I go into the details, I'd like to give you an example and walk over some of the terms that I use a lot in this talk, which are bread and butter of Quora. So here you have an example answer written by Andrew N. How does one start a career with machine learning, if I remember correctly. And so there is a question, there's an answer written by this author, there is a writer of this answer, there's also the reader of this answer, who is the one behind the screen. And the user can take various actions on the answer, such as upvotes, downvotes, comments, shares, or click, right? And there's a topic associated with this question and answer, which is machine learning. So with that cleared out, let's take a look at our data ecosystem. As you can see from this graph, we have quite intricate and complex data types and data relationships, right? So we have questions, we have answers, we have, excuse me, we have users, we have topics, and users can take various actions on answers, which I have already introduced, but they can also take various actions on questions too, right? You can follow a question, you can request answer to a question, and you can also write an answer to a question. Then users can follow each other. They can also endorse each other on certain topics. Above all that, all the questions and answers are labeled with some topics to organize its content, and topics belong to a certain hierarchical structure, right? So you can think of this as a knowledge base with added layer of social networks and topic ontology. I mentioned early on that, as of today, we have millions of questions and answers and users, and also 1,000 topics. As a matter of fact, we released some usage number a while ago, about 100 million unique monthly visitors. So we look at this and we think this is not only big data, but also very rich data. And so what can we do with them? Well, some of our data scientists will analyze the data and help us make the right product decisions. I won't go into the details here, but you can check out our data blog on a lot of these interesting findings and analysis. I can give you 2 examples. So very quickly, the first example, one of our data scientists, Shankar, did some analysis with network propagation effects of upvotes and downvotes. Another example is data scientist Don, who is in the audience today. I don't know where he is, but he did analysis of the importance of topics and semantics to understand if we have a topic network that could evolve and develop into new knowledge domains and provide a scalable scheme to organize new content as they get added to the product. So overall, analysis and studies like this help us make the right product decisions and trade-offs when needed. Now, let me get into some of the applications of the machine learning algorithms that we developed using the data that I've just talked about. And I'll start with an example of answer ranking. So basically, the problem definition is this. You have a question and a number of answers written for this question. We want to rank these answers so that the best answers stay at the top of the page. Right? It's very simple if you think about it, but also not simple because the trick is really how to define the best answers. And so different business and different products might define this in a different way according to what they care the most. But to Quora, we have our own definition and we publish it on the product as a user policy, and you can read about it. So very quickly here, we consider an answer to be good if it is truthful, reusable, well-explained, well-formatted, etc. So this is not defined by engineers or data scientists. Rather, this is defined by product teams. But what that means to the engineers is that we transform them into features that we can use in our ranking algorithm, right? So we look into features such as the text quality feature, the interaction feature, meaning the user's actions on answers and questions, and the user feature. And the last one is particularly interesting because we model the expertise of user in a certain topic and we use that extensively in our products. So for example, if there's a question about data scientist, then the answer written by a data scientist with a reputation in the field will be given more credit. So for now, the answer ranking problem is non-personalized, and hopefully at a point we'll be able to personalize that. But we do have another example of ranking that is personalized, and that is feed ranking. So feed is what you see when you go to the Quora product. You open the home page or you open the mobile app, right? This is essentially the window into the Quora world, and we want to make sure that it creates an engaging experience for the users. What that means is that we want to be able to show you stories that are high quality but also interesting to you, right? So here I mentioned interestingness, and it's defined really by multiple dimensions and transform that into, the spaces of features, right? We have topical relevance. We want to make sure that whatever we show you is related to topics that you follow or you are implicitly interested in. It has to also be socially relevant because we care about your follows and what your friends are reading and upvoting. And it also has to be timely. And also, I mentioned that we want to show interesting stories, not answers, because we're not only showing you answers in the home feed. We also want to show you questions. And that means we not only need to optimize for the probability of you liking to read an answer, but also the probability that you will likely provide a good answer to a question. There are many other challenges with this problem too. For example, potentially we might have to rank a lot of candidates. So unlike a social network like Facebook or Twitter, older content on Quora may still be relevant to some users, and we might want to show them as well. At the same time, we want to make the ranking responsive to real-time user interactions and impressions being created every single second. So, to meet all the above requirements, we adopted a personalized learning to rank approach and built a multi-stage ranking system where different sources of candidates are ranked in advance before they are finally mixed and ranked. And of course, feature engineering here is essential, right? As you can imagine, we consider various features such as the quality of the question or answer, like the text features. We also consider the topic the user is interested in or following, also the user is actually following. the past interaction history of the user on the feed stories, as well as what is generally popular and trending right now on the product. Okay, so when we launched the machine learned ranking model in feed, we see huge engagement wins. And that is a really good thing for the product and for the user experience. So I mentioned so far 2 ranking examples. At Quora, we use machine learning on other things as well. For example, recommendations. We recommend topics to users. You see these recommendations when you first become a user, when you sign on to have a Quora account. You also see these recommendations when you log onto your feed. Sometimes we inject these suggestions into the home feed for you to follow topics. And so for this kind of recommendation, it's important to know that the model not only has to consider the topics that you're already following, but also the users you're following, your past engagement history, and also several topic-related features. Think of collaborative filtering. If you can understand that the user is interested in already some topics, then how can you extrapolate from there and expand into more topics? A similar problem is recommending users. And I won't go into details here, but you can imagine that we use similar models and similar features. And here, a different feature is that we also try to understand the interactions among users and use that as a feature in the model. Okay, so another example in recommendations is related questions. It might sound less intuitive, but you get it when I explain. The problem at the high level is if we know that you're interested in a particular question, then what other questions would you possibly be interested in, right? So this is a tricky problem because most people would adopt an approach that's based purely on similarity function, and that usually doesn't work very well. So think about it. If you're following a question and you're reading answers about this question, you're unlikely to follow a very similar one unless it is more interesting or provides you more information. Right, so here what makes a good recommendation is not only decided by the similarity of the target item to the source, but also the interestedness of the target. So we have a machine learning model that considers not only the textual similarity, but also user co-visit data, topics of the question, and also in general popularity and trendiness of the question. Right. I'd like to point out that related question is very important for logged out use case, because that's effective in creating engagement from logged out users when they go to a question page from external search engine. And so we're trying different methods to kind of improve this model here. On the other hand, duplicated questions is an extreme form of related questions. Unlike related questions, which are valuable and good, a duplicated question is really bad for the product. And why? Because if we allow them to exist, then essentially we're wasting users' time to answer similar things without being able to aggregate the answers, aggregate the knowledge, right? So we really want to get rid of them. We have a binary classifier that's trained with label data, and then this model uses textual vector space models as features and also other user-based features. Okay, user expertise inference. This is a very interesting problem. So idea is we want to know for a given user U how trustworthy or how expert you are in a certain topic, say machine learning. And in order to model that, we consider features like all the answers you've written in the past on that topic, the interactions you've got on those answers from users, right? Do people upload those answers? Do people share those answers? Do they download those answers? We also consider the endorsement from other users that we already know. And this is quite interesting because it's like a network propagation model where trust and expertise could propagate through the network. Think of PageRank, but in the context of social networks. I'd like to mention that this model by itself is very useful, but it's also a very essential feature in many other ranking problems. For example, the home feed ranking problem. And this is very common in machine learning. You can train a model that's useful on its own, but it can also be used as input to other models. Spam detection and moderation. This is a huge area for Quora and very important topic for us. Why? Because we live out of user-generated content. And user-generated content can be great, but it can also introduce problems like spam, abuse, hate speech, or harassment, which are really bad. I mentioned very early on that we care a lot about quality, and so we need to do our best to remove the bad content. We started with sort of a manual approach where we have moderators who kind of check on things manually and remove them, but obviously, as you can imagine, that doesn't scale. So we developed a machine learning model that can automatically detect issues and flag bad content. But then at this point, we're not 100% trusting them. So we use kind of a hybrid approach where you have a machine learning model that flag issues and detect potential bad content and feed that into the moderation queue. It's important to note here that the machine learning model not only has to generate candidates for examination, but also need to score and rank them with priority, because this way the moderators could deal with the most important cases first. Okay. So far I've talked a lot about applications of machine learning that are sort of related to how we recommend and rank things for users to read. But recall that Quora is not just a news site where people come here to purely consume content. We also want people to write, because it's in our mission to grow the world's knowledge. Right, so here, and a very important problem is how you can do prediction of content creation. So the idea is, I want to know how likely you are to write a good answer to this question. For example, how does one start a career in machine learning? So with this question, we actually have a product feature called Ask to Answer, where once you create a question on the product, we'll have a prompt and recommend a list of users that can provide good answers to your question, and you can request answers from them. And that product feature alone is completely dependent on this prediction. By using the historic data, we can train a supervised machine learning model that predicts the labels on the new data. And then we can make this kind of recommendations with the top-ranked candidates. Okay, this I think is my last example use case, trending topics. So the idea here is that in addition to personalized recommendations on things that you already follow, we also want to highlight to you what's currently in the event or what's trending on the product. And here, obviously these recommendations need to be personalized, because we not only care about what's trending and popular around the world, but also what's popular and trending in your social circles or with topics that you're following. Now, with the example that I'm copying and pasting here, it's interesting that it has nothing to do with my interest, and that is because I steal somebody else's slides. It's not the fault of the system. Last thing to mention about trending topics is that it's a great mechanism for cold start problem and also to help with content discovery. Okay, to quickly recap, I've told you what Quora is, what's our mission, the 3 dimensions that we care a lot about and we want to optimize for, and various applications of machine learning models to optimize for these objectives. And now I want to show you something about our models and the way we do experiments. So here you can see a list of models that we use frequently in the product. We use a lot of different algorithms: logistic regression, gradient boost decision trees, deep neural nets, matrix factorization. As a matter of fact, we have just released an open source project called QMF. It's the acronym of Quora Matrix Factorization. So we are releasing implementation of some of the collaborative filtering algorithms for implicit feedback. These are very fast C++ implementation. We've actually done some benchmark comparison with available open source projects, and we noticed a 5x speed up in training time. So I definitely recommend you to check it out on our GitHub repository. Actually, let me go back one slide. So if you look at this variety of models, I'm actually not trying to sell them as necessarily a positive feature in the product. As a matter of fact, a couple of months ago, I wrote a blog post about avoiding complexity in machine learning systems. So the problem is this: if you have ad hoc implementations of tens of different algorithms, some of them in-house, some of them open source and third-party, and you don't have a good way to reuse them, then chances are you're actually introducing a lot of complexity in your system, and later on you're going to have to pay off this huge technical debt. But on the other hand, if you have a flexible infrastructure that allows you to easily plug in, reuse, and experiment with new algorithms, then why not? Right, so we have a platform in-house that we built for that purpose. We can easily experiment with new algorithms, but at the same time allow reuse of the models. So this platform is written in C++ in the backend for performance and scalability. And in the front end, we have a very user-friendly and intuitive interface in Python iNotebooks. And so this platform would allow you to easily add a new algorithm, even the open source implementation, and allow seamless integration with the product. And we found that to be really useful for data scientists and ML engineers to collaborate on projects so that you don't end up using something for experimentation and development and another thing for productionization, right? Okay, so some last note about our experimentation methods. We are extremely data-driven in making decisions. We run extensive A/B tests to optimize for various value functions and watch out for impact on the target metrics. We have also different orthogonal layers set up for experiments so that you can run separate experiments from different parts of the product. Okay, I think I'm running out of time, but to conclude, at Quora, we not only have big but also very rich data. Our machine learning algorithms need to understand and optimize for various aspects such as quality, relevance, interestingness, or user expertise. We believe machine learning is key to our success, and we've been investing a lot in them. And we have many interesting and challenging problems. And if you're excited about solving them, come talk to us at the booth. We're very happy to talk to you about opportunities with machine learning at Quora. Thank you.